having to do with chemical bonds. Put this back, and then we'll be good to go. Okay, let's review for a second. All right, looking at the periodic table, okay? We talked about valence electrons yesterday, so let's practice. How many valence electrons are in one atom of sodium? Show me in your fingers. How many valence electrons? Interesting. Okay, look at this. Sodium has one full shell, two full shells, but one in the third shell. Yes? So there's only one in that outer shell, therefore it has one valence electron. Okay? Look at the diagram. Here's sodium. It has two full shells and one in the outer layer. Okay? How many valence electrons are there in nitrogen? Well, we know it has one full shell, and then the next shell would have 1, 2, 3, 4, 5. So it will have 5 valence electrons. Yes? Okay. How many valence electrons are in chlorine? Show me on your fingers. Okay, good. 7. Here's why. One full shell, another full shell, and then 1, 2, 3, 4, 5, 6, 7. Okay? How many valence electrons are in helium? Show me on your fingers. How many valence electrons? So in the outer shell, but not in a full shell. 0. 0 valence electrons. Here's why. Helium only has one shell, and that one shell is completely full. So it has 0 valence electrons. Does that make sense? Okay. Let's do maybe one more. Calcium. How many valence electrons? There we go. Good. 2 valence electrons. Okay. New question. How many full shells does calcium have? How many full shells? Full shells. It has 4 shells total, but that last shell is not full. So it has 3 full shells. Does that make sense? Here's calcium.
Since it defied the rules, then it only achieves 2.
No. He's the last one that doesn't defy the rules. Okay? 1 full shell, 2 full shell, 3 full shell. It has a 4th, but that 4th one is not full. Therefore, it has 3 full shells. Make sense? Okay? Let's try another one. Phosphorus. How many valence electrons? Think about what I'm saying. How many valence electrons? Not full shells. How many valence? Show me on your fingers. Here we go. Ready? 1 full shell, 2 full shell, 1, 2, 3, 4, 5. 5 valence electrons.
Wait, you said 1, 2, 3, 4, 5.
1, 2, 3, 4, 5. Here's phosphorus. Here's the outer shell. 1, 2, 3, 4, 5.
Go out, like zoom out.
Oh, sorry.
To the periodic table.
Oh. Oh, you couldn't see. Hold on. You couldn't see it. Here. So this is the first shell. This is the second shell. 1, 2, 3, 4, 5.
Oh, I thought there was only 1 over there.
Sorry. No, there was 2. Okay. All right. Last question. How many full shells does this one have? Connor, up here. How many full shells did this one have? Not total shells. It's in the third row, so it has 3 shells. But the ones that are full, it only has 2 full shells. Does that make sense? Okay, so 2 full shells. Good. So, kind of getting used to practicing with valence electrons and full shells and things like that. Now, the reason why valence electrons become important is because they are what determine whether or not an atom will bond. Okay? Which is why we get into notes number 6, chemical bonds. Now, your notes on the board and the ones on your paper are actually a little bit different. So you got to give me like your full attention and really listen for when I say to write things down. Okay? So, when 2 atoms combine, they are connected by a chemical bond. A chemical bond, ignore the underlines, they're all messed up. A chemical bond is a force which holds atoms together in molecules. That's what you write. A chemical bond is a force which holds atoms together in molecules. Okay, write that first, and I'll explain what I mean. Okay, so here's what I mean by that. A chemical bond is not actually a physical item. It's not something that you can like touch or see or measure. Okay, so like on my little model here, there is no white stick connecting the 2 atoms. Okay, a chemical bond is really more like a magnet. When you take 2 magnets and put them together, is there anything holding them together? No, there's a force, a draw, or a pull that kind of draws them to each other and keeps them there. But there's not a glue, there's no stick, there's no connector point between the 2 magnets. Yes? Okay. Same thing with atoms. Okay? This is really not necessarily accurate. There's no stick connecting the 2 of them. It's really more like this. Okay? There's a force that kind of holds these 2 atoms together. Does that make sense? Like magnets. Kind of draws or pulls them together. Okay? And it has to do with the valence electrons. Now, there are 2 kinds of that force. There is either an ionic bond or a covalent bond. Okay? This word ionic, what does this sound like that we have already learned about before? Manny? An ion. Very good. We just discussed how an ion is an atom that has a different number of electrons. Yes? So it either has more electrons than it needs or less electrons than it needs, right? Giving it either a positive or a negative charge. In an ionic bond, when those 2 atoms come together, one atom actually gives electrons to the other. Okay? So let's pretend the green atom gives electrons to the orange atom. This atom now becomes positively charged because he has more protons and electrons, while this one becomes what charged? Negatively charged because there's a lot more electrons going to it. See what I'm saying? Okay. That's an ionic bond. When one atom gives away or donates electrons to another one. Okay? Covalent is like a co-partnership. They come together and instead of giving electrons away, they share electrons so that they both have what they need. Does that make sense? Yes. Okay. So let's look at the board over here real quick. I'm going to show you ionic bond. Oh, they cannot see that. Let me do it this way instead. Huh? Not yet. No, I will give you the definition to write for ionic bond. Okay. Sure. Actually, all right, let's take 2 atoms. Let's take sodium and chlorine for right now. Okay? Sodium and chlorine. One atom of sodium, we know, has an atomic number of 11. So that means it has 11 what? Protons. Connor, I have your attention, right? Okay. Sure hope so. Now, over here, I have another atom. This one I'm going to make chlorine. Okay? Chlorine, we know, has an atomic number of 17, meaning it has 17 what? Protons. Okay, so now we're going to do the electron configurations for both of them. Okay? Start with sodium. Sodium has 11 protons, so how many electrons do I need? 11. Good. How many can I put in the first shell? 2. Okay, so 1, 2. I need to keep going, so I got to add a second shell. Okay, so count with me. We got 1, 2. We're going to go to 3,
4, 5, 6, 7, 8, 9, 10.
My second shell is now full, right? It's got 1, 2, 3, 4, 5, 6, 7, 8. Do I have enough electrons yet? No, I need one more. So I need a third shell. With that electron. Now I'm good, right? Okay, now let's do chlorine. Chlorine has 17 protons, so I need 17 electrons. How many go on the first shell?
2.
How many on the second shell?
8.
Okay. Those are not spaced out very well, but that's okay. How many more do I need?
7.
Yes, I need 7 more. I've got 10 right now, right? 2, 1, 2, 3, 4, 5, 6, 7, 8. That one's full, that one's full. So I'm going to add my third shell. How many more do I draw? 7. Got 1, 2, 3, 4, 5, 6, 7. Okay. Now, remember how I told you that atoms need to have that full outer shell in order for them to be quote unquote happy, right? Okay. They they will not rest until they have that full outer shell. Yes? Let me see how they okay, good. So what they will do is they will either gain electrons or lose electrons to have a full outer shell. How many more does sodium need to have a full outer shell?
7.
7. Very good. It's got 1. It needs to have 7 more. How many more does chlorine need to have a full outer shell?
1.
1. It only needs 1 more. It's got 7 in the third shell. The third shell needs to have 8 to be full, so it needs 1 more. What do you think will be easier? For sodium to find 7 more electrons hanging out somewhere, or for chlorine to find 1? Chlorine to find 1, exactly. So here's what happens. Sodium will actually get rid of this electron. It will give it to chlorine. When that happens, sodium, it doesn't have an electron in that outer shell anymore, so that last shell goes away. Now, does sodium have a full outer shell? Yes, it does. This shell is already full. It lost the third shell, but that doesn't matter. The outermost shell now is full, correct? So is sodium happy? Yes, he is. Chlorine, he now has 1, 2, 3, 4, 5, 6, 7, 8 in his outer shell. So is he happy? Yes. Okay. This donating of the electron is the ionic bond. And that's the force that holds these two together. Okay? Now, sodium, it's ionic, and I'll prove it. Look, sodium has 11 protons, but how many electrons does it have now?
10.
10. So if it has 10 electrons, is it an ion with a negative charge or a positive charge? Positive, because the positives are more than the negatives. Yes? So this is a sodium ion with a positive charge. What about chlorine? Well, he's got 17 protons, but 18 electrons. So he's an ion with a what charge?
Negative.
There we go. You see how it's ionic? Good. Ionic. Now, that's how you can tell an ionic bond between really any two elements on the table. Okay? They have to fit together like a puzzle piece. Okay? Think about this. Chlorine, we just said, had 7 valence electrons, right? It needs one more. Well, any of the elements in this group have one to give, correct? They all have 1 valence electron, so they fit like a puzzle piece. If you try to put chlorine and magnesium into a bond together, it's not going to work. Magnesium has 2 electrons, 2 valence electrons to give, right? But chlorine only needs 1, so they don't fit together. You see what I'm saying? That's why you can't just take any 2 random atoms and say, oh, they'll bond. No, they may not. Depending on the number of valence electrons, they may or may not form a bond. Does that make sense? Okay. That's also why all of the elements here in group 18, they never bond. Why? Well, because they don't need any more. All of their outer shells are already full. They're good to go. Okay? You will never find these in any kind of compound with anything else. They can't bond. There's no way. They're already full. Does that make sense? Okay. That is the ionic bond. Okay? I'm going to go back to the PowerPoint. We're going to write the definition. And then on Monday, we'll go over covalent bonds. Okay? A different kind of force that happens in a different way. So, first, we're going to count the number of electrons received as the bond. So, chemical bonds are determined by how many electrons are in the atom's outer shell. How many does carbon have? Count.
1, 2, 3, 4.
So it's got 4 valence electrons. It can either give away 4 or it gets 4 more. Magnesium, how many does he have?
1, 2.
Good. So he can only form a bond with the other atoms that need 2 more electrons. Neon, how many does he have?
1, 2, 3, 4, 5, 6, 7.
How many valence electrons?
0.
0. Exactly. Because he's full. Make sense? Okay, Connor, I'm going to give you demerit. You're working up here and you're doing absolutely nothing to get with it. But do it only pay attention. Yes. Yeah, exactly. He's got a big lunch and he's full. Okay? Alright, so for your definition for ionic bond. Nope, just kidding. That's not it. This one. An ionic bond is when one element donates an electron or electrons to another so that both elements will have a full outer shell. For example, sodium and chlorine, like we just did. By the way, that combination right there, that is salt. It's an ionic bond between sodium and chlorine. Okay? So once you finish writing that, we will go over covalent bond on Monday. It's similar, but a little bit different. Electrons aren't given away, they're shared. And we'll see how that happens on Monday. Okay? Yes? I know, it went by fast, huh?
Really?
Lots of explaining.